This video is going to show you how to do some calculations with solutions. So the first calculation we need to look at is the calculation for molarity. Molarity is the concentration of a solution, and it's usually given in the units moles per liter. Molarity uses the symbol M, that's its abbreviation, and it's a capital M. And when a solution is diluted, more solvent, usually water, is added to it. The volume is increased by the addition of the solvent. To calculate a new concentration of a solution, you're going to use the equation M1V1 equals M2V2. And M1 is the initial molarity or concentration, V1 is the initial volume, M2 is the final molarity, and V2 is the final volume. And this probably looks pretty similar to the Boyle's law equation that we used in the last unit for gas laws. And you're actually going to set it up and solve it the same kind of way. So let's look at an example. This example says that water is added to 200 milliliters of a 2 molar solution of calcium chloride. So we know right off the bat we can pick out some variables. 200 milliliters is going to be our volume 1, and 2 meters is going to be our molarity 1. And the question goes on to say it adds the water to that solution to increase the volume of the solution to 400 milliliters. So right there I see 400 milliliters. That's my second volume because it was increased to that. So it wants to know what is the new concentration. Your new concentration is going to be your M2, and that is our unknown. That's what we're looking for. So you can see they just listed those out, the same ones that we underlined. So now you're going to set it up and just plug in your values. So M1 was 2.0, V1 was 200, M2 is what you're solving for, and V2 was 400. And then when you do the algebra to get M2 alone and solve for M2, you're going to come up with the answer of 1. So that's your answer for this problem. And that's how you would solve a molarity or concentration problem using the formula M1V1 equals M2V2. Now we're going to talk about some unique properties of water. Listed here are all the properties we're going to talk about, and we're going to go in depth on each one on the next slides. First up is the molecular structure of water. You've probably seen this picture before. Some people call it the Mickey Mouse. That is a model of what a water molecule would look like. So it's got one oxygen atom, so you can see the oxygen atom is this big red one, and it's got 2 hydrogen atoms on the side, and that makes up the formula H2O, 2 H's, 1 O. It's not symmetrical, it is polar, and the electrons are going to be spending more of their time near the oxygen and less near the hydrogen. Another unique property of water is hydrogen bonding. This is because positive charges are attracted to negative charges. Remember, those opposites attract when it comes to our charges. And each H2O is going to be bonded to its nearest neighbor. So you can see here, here's our oxygen, it's got kind of a negative charge, and here's another hydrogen, and it's got kind of a positive charge because of that polarity, and those two things are drawn towards each other, and it creates what we call a hydrogen bond between them. And you can see the same things happening between all of these different molecules of water. Cohesion is the attraction of water to itself, and that is another property that comes from those unique hydrogen bonds formed between the molecules. Adhesion, not to be confused with cohesion, is the attraction of water to other surfaces or substances. So adhesion is water wanting to stick to other things. Cohesion is water wanting to stick to itself. And they're both properties that come about because of the hydrogen bonds between the water molecules. Surface tension is another unique property that water has. You've seen this before if you've ever seen one of these cool spiders that walks on the water, or if you've seen something very light like a paper clip float on top of the water. So surface tension is basically just the interaction between those hydrogen bonds and the Earth's gravitational pull. So gravity is pulling things down, making them want to sink, but those hydrogen bonds are holding the water molecules together, which causes things to be able to sometimes float right on the top. As we said in part 1 of this video, water is what we call the universal solvent. It's a polar solvent, and so it's going to dissolve polar solutes. Non-polar solvents, remember, are going to be dissolving non-polar solutes because like dissolves like. Since water is polar, it's going to dissolve other things that are also polar. A very high heat capacity is also another property of water. We call this the specific heat, which is the amount of energy required to change the temperature of 1 gram of a substance by 1 degree Celsius. Basically, it just means how much energy you need to heat something up. Water has a very high specific heat, meaning you would need a whole lot of heat to heat it up. That's why it tends to stay cool. Water absorbs a lot of heat before it starts to get hot, and that's used as a way to moderate our weather. The final property of water that we're going to talk about in this video is called capillary action. Capillary action is best understood by just looking at this picture here. So you can see here in this little tube, the water is sticking right there on the sides and pulling itself up. Same thing here, you can see it kind of more dramatic. And over here you can see in that small capillary tube, it's really pulling itself up on the sides. So this is because wettable surfaces cause a film of water to partially pull away from the other water molecules and cling to their surface. And capillary action is something that's really important for life because it is in soil, it's in our blood, and it plays a huge role in plants. It's how plants get their water from their roots up to their important parts, and in our soil. And that is it for your unit on solutions. Hope you enjoyed it.